Hey everyone, welcome back to another episode of Mailbag. This one is a mechanical Bonanza. I cannot wait to open these two, so I'm going to open them first, and then I've got one off-topic one for the end. Let's get started. Okay, this one here is going to need a sense of scale. So this here is the motor that comes with mini lathes. And I think this is what's called a 775 motor. Most RC car motors are smaller than this. They are a 540 motor. So this is already a Chungus motor. What's in here though should be the biggest motor series you can get, called the 997 motor. In fact, there should be two of them. They're not quite the size of a Coke can, but they are like as big as they get before you get into specialty motors. So here's hoping they made it intact. Oh yeah, this was quite expensive also. $80.95. July 5th order, July 18th arrived. And actually this is the third time I attempt to buy these motors because I think the first time they didn't arrive, I had to open up a dispute. Give me my money back. The second time, the seller said, "Oh yeah, I know we said, it was this much to ship, but the shipping company wouldn't take it. So they had to refund me my money." And now, here they are. This is a 997 motor. Look at the size difference. This thing is huge. Holy crap, it's got a 6.5 millimeter shaft. It's supposed to be good for the better part of 400 watts. That's over half a horsepower. This thing is giant. And I've got two of them. I am delighted. I mean, they give you the dimensions on paper, right, for how big these things are going to be. But, I mean, until you have them in your hand, that is just ridiculous. Look at the Chungus. And, like, honestly, this here feels like a big motor up until I handled this. So, the deal with these motors is that I wanted to buy them, or I wanted to buy a different motor, I should say. And then I thought, well, I don't have any money, I'm not working, so I'll just wait till my project is further along, and then I'll buy it. Big freaking mistake. The motor that I originally wanted for this project became unavailable at under $150. So my solution, instead of one big motor, is I was going to go these two. I mean, I hesitate to call them small. They're huge. But these 997 motors. But then as soon as these came in the mail, the one that I had originally intended for my project came back in stock for a reasonable price. So this one was $70 plus tax. But this was at the Amazon. It was at Amazon. It was local delivery. Oh my god, this thing is so big. Oh. Oh. So let me reiterate. This is a big motor, a 775 motor. This is ludicrous, this 997 motor. This is beyond all reason. This is what's called a MY1020. Sorry, the scale is So this is the motor I was intending to use for my project. And I don't really want to say what the project is, but a lot of you, maybe if you listen to my podcast and stuff, maybe you know what it is. But this is a 24 volt 500 watt motor, but more than that, it'll have torque to spare. This is this is gonna break my wrists. But that's the goal. So yeah, it's got relatively thick wire here. But if you're wondering why I was ordering a whole bunch of motor drivers, this is the reason. So this is supposed to power like a scooter. This is supposed to power me, move me around. But oh my god, this thing is honestly, this is heavier than my trolling motor I have on my boat to push me around the lake. I'm sorry. This is ridiculous, but I'm going to have tons of fun playing with these things, and I hope you give me your best guesses as to what I'm building with this. If you already know what it is, then you know how much trouble I might be in. But yeah, this should be fun. On to the next one. Oh, sorry, I couldn't resist. This is a 540 motor. So this is a 540. That's a 775. That's a 997. And this is what's going to power my project. So this can push an RC car up to somewhere around 60 miles an hour. Maybe not 60 miles an hour, 50 miles an hour. This can mill through aluminum, not a problem. This and this is just going to be insane. Okay, next one up. No more giggling this time, hopefully. July 5th to July 20th, $17.10. This is part of a long-term project. Some of you who are listening to the podcast know what this is about. Yeah, I just haven't gotten my hands yet. So I have this plan to build a open source remote control vehicle. More of a vehicle platform, you know, so you can kind of do whatever you want to the platform. 5, 6, 7, 8, 9, 10. Yeah, so these are ball bearings, and these are the bearings that I intend to use on the steering knuckles. How do I explain this? Let's see if I can do this coherently. So this is my crashed remote control car from a long time ago. And basically you can see that there's parts of the car that are not the wheel. See, that part is stationary. It doesn't turn, but the wheel turns. So basically how it works is there is this purple part here called the steering knuckle. And inside of that there's like a cup here which holds the axle, the drive shaft, and it goes right through, and it's that nut you see at the end there, that it's right through to there. So that is how the wheel works. So that knuckle, that hub, has a part going in the middle holding the wheel and also transferring the torque from the transmission through to here. So in the 3D printed version, the goal is going to be to reduce the amount of part count. So you just have to order, one order of one type of bearing, for example, keep in stock, and then you can replace them as needed. So these were my choice for the knuckles because there are really big remote control cars that use these exact bearings. These are the upgrade for the Traxxas X-Max, which is the X-Max? Anyways, the big one, the 5th scale one. If you upgrade the hubs on top of that, or the steering knuckles on top of that, these are the size bearings that go in there. So these are 20 millimeter inner diameter, 32 millimeter outer diameter, and 7 millimeter thickness. And how this is going to work is they're going to sit sort of side by side like this in a steering knuckle, and then they'll have the center components coming through and holding the wheel. Now, these bearings, as you can see, are absolutely tiny, but they have the advantage that the center part here can be made of metal. Mine will be made of plastic. So I need to get a lot of plastic through here in order to be strong enough to support kind of the weight of the vehicle crashing down on the wheels. So the goal is, I think 20 millimeters will be enough. And at the same time, the part that these are going to be pressed into, the knuckle, is going to be small enough to fit inside of a wheel that is small enough that you don't stack up large parts like crazy. So that's my plan with these. I think, they were cheap enough for a set of 10 that I think, you buy a set of 10 of these, and that should be enough to do, 4 wheels, because 2 per wheel, so that's 8. And then there might be 2 more needed for the differential on the sides. We'll see. I may need to order 1 more size for drive shafts or something like that, but if that's the case, it is what it is. But I'm going to try to stick to having just this one size of bearing, so that those of you that want to print your own, all you're going to need is a 3D printer and, just order a few of the same components, right? So like 10 bearings or 20 bearings or whatever, but they're going to be the same. And then you'll have to just order M5 screws type thing. So instead of having a parts list that's like 1 million parts long, you're going to have a parts list which is just 5 or 6 parts, and then you just have to order more than one. So hopefully that made sense. Trying to explain it here, I'm not sure if I'm making much sense, but yeah, basically I want to keep the individual part count down, so you just order more of the same part instead of ordering 100 different parts. Because especially in a world like today where the shipping is getting really expensive, I would rather just order many more parts from the same seller than have to order from 100 individual sellers. Hopefully that makes sense to you. But yeah, that's my plan, and I'm hoping it'll work. We'll see. Next one up is this one here. I genuinely forgot what it is. July 5th was ordered. 17th it came in. $14.75. I don't know. We'll see. Maybe it's another off-topic one, actually. That's a thought. Oh yeah, okay, so I do remember. So this is for the projects with the motors. So this big boy right here comes with a chain, as you can see, or a chain drive. No chain. You got to supply your own chain. I don't like chains. They're quite noisy. And these guys didn't come with any drive mechanism at all. So I figured I would order some GT2 belts in closed loop. And I would order a couple different sizes of them until I figured out what kind of size I need. So this is a GT2, or they call it a 2GT. Basically, the 2GT is it's the updated, slightly more torque version of the GT2. But these are 1500 or 15 millimeters wide. They ride on same sort of pulleys as you would see a 3D printer belt. It's just much wider, and this will go over a gear here, or pulley here, and then here to a shaft to spin my target. Now, I didn't know what size I needed. That's why I got a variety, so I can design to envelope. The goal was to not need any of these at all. I wanted to just have the shaft go directly coupled onto here, but it seems like it's not going to be doable without this big boy. So when I designed with these in mind, how it's going to work is there's going to be basically both of these on like this, and then a drive gear in the middle. And I'm seeing now, just seeing the amount of spacing I'm playing with, I'm probably going to need longer belts than this. So I believe this is 300 mil, 200 mil, 300 mil. The second one, I bought 2 of each. 250 mil and 250 mil and 200. Yeah, so 2 200 mil belts, 2 250 mil belts, and 2 300 millimeter belts. And it seems like they're going to be too short unless I use you know, 2 pulleys, one for that one and one for the other one. But it's good to know. I mean, it's very hard to design in your head, at least for me, to design in my head without having access to these components to hold in my hands and to have alongside when I design. I'm also seeing that the teeth are frighteningly small. So I may have to go with another tooth belt. So if you have a suggestion for a tooth belt that can handle a lot of torque, I mean, we're talking about 800 watts between these guys, just over a horsepower. If you have an idea on how I can drive a horsepower through a tooth belt with cheap belts, I don't want to buy, you know, some sort of Gates one-off type belt, because I need to be able to 3D print the pulleys. Let me know in the comments, but these guys will probably go to experimentation at the moment, because the project that I want to do with these motors is kind of difficult, but in the meantime there's lots of fun stuff we can do with these. So let me know if you got an idea. And the last on topic one, this was, I believe it was $13 or something. I got it from Amazon. That's why it's not in a fancy bag. It was actually with some other stuff I ordered, so that's why it's by itself. My solar video, I need to be making that very shortly. And I do have a fancy solar charge controller, but I didn't have a cheap one. And the goal of my cheap solar setup video is that I want to show you what kind of efficiency and what kind of numbers you're going to get with the cheapest gear possible. And then I want to make subsequent videos upgrading that gear. So this is literally, you can get them on Amazon when they're on sale. They are literally around $10. Like, they are so cheap. I paid a bit more because I want to do the video shortly. But yeah, this is a PWM Solar Charge Controller, as basic as it gets. You plug in your solar panels here, plug in your battery here, and you plug in your loads here. It's got a some USB output, so you can power some micro if you want, or your cell phone. And this just basically pulses the PWM cycle in order to charge the battery as efficiently as possible through the solar cell. This is not the most efficient way to charge a battery. MPPT would be the most efficient, where it actually regulates the voltage. It boosts or bucks the voltage depending on what the battery needs. This one here, it'll just pulse on and off the solar panel. That's it. So I want to show you that you do not need the top spec stuff in order to use your solar panel, and you can build a solar system, solar charge system, for very cheap. And so this is going to be part of the cheap video, and then we're going to compare it to a fancier MPPT controller after. Now I paid a little bit more for this one because this one's good up to 30 amps, because I'm also going to want to see how it's going to be to connect more than one solar panel to this in series. This one should be able to accept a couple in series. The instructions should say so. Up to 36 volts, is that what it says? What model is this? RBL 30ACA. AC? 23 volts. With 12 volt battery, 24 volt battery when you're up to 46 volts. So yeah, you can put a couple of solar panels. I've got 3 solar panels here now, and I plan on hooking them all up and just pushing this thing as hard as it goes to see how we end up. So actually I have 4 if we want to stretch it. So yeah, hopefully you're looking forward to that, because I know I am. And the final item up, this is not a electronics item, so feel free to skip to the outro if you'd like. This one, July 5th ordered, 17th arrived, $4.34. And this is one of those things that I just need on an ongoing basis, and it's just cheaper to get it from China. This is a wallet. It's probably not genuine leather, but it doesn't matter. I buy these really cheap on eBay and AliExpress and whatever. I typically rip out this zipper because I don't have any need for change, and just carry my cards with me basically. Feels pretty good for what it is. And yeah, so this is like $4. They last me about 3 years or so. So $4 every 3 years, pretty good. And that's that. Very basic looking. Looks pretty neat. Just needs to hold cards, and seems like it'll do just that. Wallet. They're cheap. And so that's it. The mechanical Bonanza. Thank you again to my Patreon patrons. I am working now, and that's why I felt more comfortable spending some Patreon money on some cool project things. But it's still thanks to them that this channel is less in the red, I guess. I mean, between them and the sponsorships, it's nearly cost neutral if you don't count my labor, which, you know, I'm a YouTuber. Who does? But if you guys really want to see these things tested and play with, of course, let me know in the comments below. But I'm going to take a few of the motors around the shop, and I think I'm going to see if I can test how good they'll work as generators. That should be a pretty nice intro to these electric motors. Anyways, thanks for watching.